On May 24, 1962, astronaut Scott Carpenter climbed into Aurora 7, unaware that his flight would redefine our view of space. As he orbited Earth, malfunctioning instruments and treacherous currents conspired against his safe return. Remarkably, his calm demeanor and swift improvisation kept him alive, even as radio signals faded. Yet decades later, a lingering mystery endures. Did Aurora 7's true heroics ever receive the recognition they deserved? Join us as we unravel the untold story, rediscover forgotten audio logs, and confront the unanswered questions still haunting NASA. What really happened during those final harrowing minutes before that fateful splashdown? At 10:04 a.m. Eastern on May 24, 1962, Mercury Atlas 7, christened Aurora 7, thundered skyward from Cape Canaveral, marking NASA's third crewed orbital flight. The sleek capsule, just 9 feet across and weighing 3,000 pounds fully fueled, housed a single pilot, hydrogen peroxide thrusters, and a pressure suit built for survival at Mach 25. Scott Carpenter completed 3 Earth-circling laps, meticulously running navigation experiments and probing human physiology in weightlessness. But as re-entry unfolded, a puzzling yaw sensor failure and an extended retrofire burn sent Aurora 7 into a tumble, forcing Carpenter into manual mode he practiced but never fully tested. With radio chatter fading and splashdown miles off target, his calm command of the controls secured a safe return. Aurora 7's bold mission not only pushed our technical boundaries but also planted unanswered questions in NASA's legacy, questions we're still chasing today. Rising from the pad in gleaming silver, the Atlas launch vehicle began life as Convair's revolutionary ICBM before becoming NASA's workhorse. Its unique stage-and-a-half design paired a central sustainer engine with 2 jettisonable boosters, maximizing thrust without the complexity of full staging. On December 17, 1957, the first Atlas lifted off, proving LOX/RP-1 propulsion and thin-skinned, pressure-stabilized tanks could carry hefty payloads into space. Adapted for Project Mercury, Mercury Atlas 6 propelled John Glenn into orbit, cementing its legend. Over the decades it evolved through Atlas 2 and 3 to today's Atlas 5, now powered by the Russian RD-180 core engine, optional solid boosters, and modular fairings, delivering everything from GPS satellites to interplanetary probes. Half a century on, Atlas remains a testament to engineering ingenuity, bridging Cold War origins with 21st-century exploration ambitions. At 10:45 a.m. on May 24, 1962, Scott Carpenter became the second American to orbit Earth, yet his story stretches far beyond those 3 laps. Born in Boulder, Colorado, in 1925, Carpenter honed his precision flying as a Navy test pilot, mastering high-speed jets and experimental aircraft. Selected in NASA's original Mercury 7 in 1959, he brought a scientist's curiosity to the astronaut corps, insisting on carrying handheld cameras and even live seafood to study motion in weightlessness. Once aloft in Aurora 7, Carpenter meticulously ran 6 experiments, charting star positions for navigation, measuring radiation belts, and observing his own bodily fluids in microgravity. But when a urate sensor failed and he overburned his retro-rocket, he found himself battling unexpected tumbles and drifting hundreds of miles off target. Relying on his calm training, he switched to manual control, splashed down safely, and floated, tethered only by his survival kit, while recovery ships pinpointed his capsule. After NASA, Carpenter dove into oceanography, commanding deep-sea submersibles and mapping mid-Atlantic ridges for NOAA. He championed marine conservation and even piloted Alvin's predecessor Under the Waves. His dual legacy, as pioneer of both space and sea, reminds us that exploration isn't limited by atmosphere or depth. Next, we'll dive into Carpenter's forgotten audio logs, compare his mission to John Glenn's, and explore how his scientific rigor reshaped human spaceflight and inspired a new wave of ocean explorers.
T-minus 60 seconds.
Test conductor, Mercury is go.
GM, yours at 2 minutes. Minus 45. Get a good final RNZ? Minus 40. 40 seconds. Status check. Pressurization, go. Blocks tanking, go. Water system, go. Range operations, go. You're clear to launch. Mercury cap, go. All 3 start lights are correct. The range ready light is on. 26. Eject Mercury umbilical. Retract light. Scope is clear. All evacuate.
Scope is in, light is out.
Roger, start scope. Mercury is go.
Scope is in.
All reporters to pad. All evacuate, light on. T-minus 18 seconds and counting. Engine start.
15.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
I feel the liftoff. The clock has started.
Roger.
Loud and clear, Gus.
Roger, Aurora 7, stand by for your time hack.
Roger. A little bit of shaking. 4,
3, 2, 1, mark.
Roger, the backup clock has started.
Roger, Aurora 7.
Clear blue sky. 32 seconds, 9,000. Fuel and oxygen steady. Cabin pressure 51 and dropping. A little rough for max Q. 1 minute.
Roger, you're looking good from here, Scott.
25 amps and the power is good.
Roger, you're looking good.
Mark, 1 minute. Cabin pressure is on schedule. Fuel and oxygen are steady 24 amps. All the power is good.
Roger, pitch is 56, you look real good.
Roger, my pitch looks good. Moving down a little bit now. Feel the pitch program starting over.
Roger.
Sky is getting quite black at 1:30. Elapsed. Fuel and oxygen is steady. Cabin pressure is leveling off at 6.2. 22 amps and the power is still good. A 1 CPS sway in yaw.
Roger, understand. Pitch is 37, you look real good. Stand by for staging.
Roger, there's Pico on top.
Roger, understand, Pico.
Roger, I felt staging. Do you confirm?
We confirm staging.
Do you confirm staging?
Aurora 7, we confirm staging.
Mercury Control. The United States launched its second manned orbital spaceflight with astronaut M. Scott Carpenter at the controls at 0745 a.m. Eastern Standard Time here today. The purpose of the flight is to continue the investigation of man's capabilities in space, leading toward manned flight to the moon and return. This is Mercury Control.
10 seconds to go.
Okay. There is Pico. Deposit grades fired. I am weightless and starting to fly the large turnaround. Stamp is good.
Roger, you look good down here.
Periscope is out.
And Aurora 7, we have a go with better than 7 orbit capability.
Roger. Fleet words.
Roger.
Aurora 7 is in orbit. The men in the blockhouse have done their job, and the Atlas booster has done its job. Now, it's up to Mercury Control and the tracking network, the spacecraft, and the astronaut. 99 miles high over the Atlantic, traveling at more than 17,000 miles an hour, Scott Carpenter goes to work.
I have the moon in the center of the window, and the booster off to the right slightly.
One of his first jobs was observing and photographing the burned-out Atlas as it trailed him into orbit. At this time, he discovered that by means of his attitude control system, he could successfully track and orient his spacecraft in relation to the trailing booster. This information will be useful in planning future orbital rendezvous missions. Approaching Africa, radio contact is made with the Mercury tracking station at Kano, Nigeria.
29:43, the first time I was able to get horizon pictures with MIT film, set at f8 and 1/25. A picture to the south, into the sun, directly down my flight path is number 2.
As the Aurora 7 sped across Africa into the sunset, the astronaut began his continuing study of the space environment. The haze layer noted on the prior flight of Freedom 7 was now measured for light wave frequency, breadth, and width. Star observations were made for occlusion and intensity. Venus was clearly observed low on the horizon. Experiments were conducted on drifting flight, as well as the effects of spacecraft control by body movement and orientation with the darkened Earth. Body movement and proprioceptive tests were conducted during prolonged weightlessness. Observations were periodically made of the liquid behavior experiment. These observations confirmed suspected surface tension effects under the weightless condition. And always the endless task of communication with the Mercury tracking station. Mouchet and Woomera, Australia.
Hello, Mouchet, Capcom, Aurora 7, loud and clear, help me.
See you loud and clear also. What's your status?
Canton Island in the dark Pacific. Out of the night and into a sunrise. And at sunrise, the first of the space particles.
I have the fireflies. I have the particles. I was facing away from the sun at sunrise, and I did not see the particles. Just after yawing about 180 degrees, I was able to pick up at this. Stand by, I think I see more. There was one, random motions. Some even appear to be going ahead. There is one outside. Almost like a light snowflake particle caught in an eddy. They are not glowing with their own light at this time. And mark coastal passage.
Say again?
Mark coastal passage coming over the Baja.
How does it look?
Half covered with clouds, and the other half is dry. Will you pass on this message for me, Gordo, to all the troops at Guaymas? Hola, amigos. Felicitaciones a México y especialmente a mis amigos de Guaymas. Desde el espacio exterior, su país está cubierto con nubes and es also se me muy bello. Aquí el tiempo está muy bueno. Buena suerte desde Aurora 7.
Roger. Muchas gracias, amigo.
Okay.
It takes Aurora 7 just 8 minutes to cross America from the Pacific to the Atlantic. And over the homeland, repeat the endless checks on blood pressure, suit temperature, control mode, fuel consumption, time. And now, approaching Bermuda, the balloon experiment.
Aurora 7, did the balloon inflate?
The balloon is partially inflated. I would say we have about a 1 cycle per minute oscillation. It's both in pitch and yaw.
After release, tensiometer measurements and observations against the blackness of space. Of the 4 colors, only orange and silver seemed clearly visible. Then, visibility studies and studies of depth perception in space. Experiments with food consumption and handling. Scott Carpenter swinging in a long arc across Africa.
Yes, I have. However, the food has crumbled badly, and I hate to open the package anymore for fear of getting crumbs all over the capsule. I can verify that eating bite-sized food as we've packaged for this flight
is no problem at all. Even the crumbly foods are eaten with no problem. Go ahead, Indian Capcom. That's very good. I guarantee I'm breathing.
On the third orbit, Aurora 7 approaches the California coast and the critical retrofire maneuver. Scott Carpenter identified the mysterious particles as frost, dislodged from the exterior of the spacecraft. But now, the fuel supply is very short.
Gyros are off.
Right, you'll have to use attitude bypass, man, and manual override.
Roger.
4, 3, 2, 1, 0.
Okay, fire 1, fire 2, and fire 3. I had to punch off manually.
Aurora 7 faces one more obstacle as it speeds across the United States. As the spacecraft encounters the atmosphere, its speed and energy are translated into heat through friction. 3,600-degree temperatures 3 feet from the astronaut's back. An ablative heat shield dissipates the heat, but the enormous temperatures create a layer of ionized air around the spacecraft, which blocks communications.
Roger. Yes, but I can't get anything out of it.
In Mercury control, every second seems an hour as the communications blackout begins. But Scott Carpenter continued to record his observations on a tape recorder in the spacecraft.
My fuel, I hope, holds out. There is 1G. Getting a few streamers of smoke. Out behind, there's some green flashes out there. Entry is going pretty well. Oxdamp seems to be keeping oscillations pretty good. We're at 1.5 Gs now. There was a flaming piece coming off. Almost looked like it came off the tower. Oh, I hope not. Okay, we're reading 3 Gs. I think we'll have to let the re-entry damping check go this time. Reading now 4 Gs. The re-entry seems to be going okay. And it was just in time. Main deploy. Fuse switch is on now. 21 indicated. Snorkel override. Now, emergency flow rate on. Emergency main fuse switch at 15. Standing by for the main chute at 10. Cabin pressure, cabin altimeter, agree on altitude. Should be 13,000 now. Mark 10. I see the main is out and reefed, and it looks good to me. The main chute is out.
Aurora 7, Cape Capcom, over. Aurora 7, Cape Capcom, over.
Cape, do you read yet?
Aurora 7, Cape Capcom, over. Aurora 7, Cape Capcom, over.
Aurora Capcom, he's pretty far downrange.
Aurora 7, Cape Capcom, over.
Trajectory data flowing through the high-speed computers at the Goddard Space Flight Center provide a landing point prediction. Aurora 7 will land some 250 miles farther downrange than anticipated. Recovery forces order flank speed toward the predicted landing area. Scramble all search and rescue aircraft aloft. Alert pararescue personnel and all medical and emergency teams.
Aurora 7, Cape Capcom, over. Aurora 7, Cape Capcom, over.
In the recovery room at Cape Canaveral, the predicted landing point is charted, checked, and rechecked. Predicted time to recovery, 1 hour. The long wait begins.
Our data at this time indicates that it is distinctly possible that the Aurora 7 spacecraft may land considerably longer downrange than it was planned. Our present estimate of his landing point may go as far as 200 miles downrange. For that reason, we feel that his ionization period now is over, that he has exceeded the range of our transmission equipment here at Cape Canaveral. We are diverting aircraft into the area, both for the purpose of reestablishing communications and effecting a rescue operation. This is Mercury Control.
Then, contact with the Aurora 7.
A U.S. Navy P-2V aircraft in the landing area has received an electronic contact from a device called a Sarah beacon. We do not have any further details at this time except that he has made the contact and has taken a bearing on the source of that signal. He is now diverting his aircraft into that immediate area. This is Mercury Control.
Aurora 7 set out with 3 clear objectives: prove a man could live and work in orbit for an extended period, test celestial navigation and spacecraft systems under real-time conditions, and gather biomedical and environmental data to guide future missions. Specifically, Scott Carpenter would chart star positions against Earth's horizon for manual attitude control, measure radiation levels in the Van Allen belts, and photograph coastal landmarks to refine Earth view reconnaissance techniques. By the time Carpenter splashed down, Aurora 7 had chalked up impressive wins. He completed 3 full orbits in just over 4 hours, executed 6 different experiments, ranging from micrometeorite detection to fluid behavior studies, and proved hydrogen peroxide thrusters and life support systems could sustain human activity at Mach 25. His calm manual piloting when the autopilot quit became a textbook case in astronaut training, and the mission's biomedical data laid groundwork for longer Gemini and Apollo voyages. Yet Aurora 7 wasn't flawless. A urate sensor glitch led to a longer-than-planned retrofire burn and sent the capsule tumbling before Carpenter switched to manual control, braving garbled radio uplinks and drifting nearly 250 miles downrange. His overshoot triggered a delayed recovery, leaving him bobbing offshore longer than expected and raising questions about re-entry guidance reliability. These hiccups forced NASA to overhaul instrument redundancy, refine retrorocket timing, and sharpen splashdown prediction models, lessons that turned Carpenter's close call into invaluable course corrections for America's next giant leaps. In conclusion, from Carpenter's improvisational calm as the capsule tumbled to the biomedical insights that paved the way for Apollo, Aurora 7 embodies both human resilience and NASA's commitment to learn from every victory and glitch. This mission taught us that exploration isn't flawless, it's an iterative climb where each hiccup refines our reach for the stars. As we salute Scott Carpenter's legacy, we're reminded that spaceflight demands equal measures of rigor and ingenuity.